So here we're given a rectangular object or material. I think it's cardboard in this one. We're trying to fold it up into a box, and we're also trying to maximize the volume, so basically make the biggest box we can. So notice, what do we get to decide on here? Well, how much should we cut out of each side? Because whatever we do, it has to be symmetrical, so it'll fold up. This kind of reminds me of those little like gift boxes you get at Christmas from the department store kind of thing. So we're going to decide how much to cut out of each little portion here. So our squares, whatever we do, it's all going to be symmetrical. And so notice, let's just physically do that so we can see kind of more how it's going to fold up as a box. So if I cut out these corners, and I cut out space here so that I can have another edge to it, so all of these little parts are all X. So then notice, if I fold up the sides here and then fold it, I can make one closed box. All right, so volume is length times width times height. But we have to be careful. Our length and width aren't 8 and 5. It's the length and width of the box we end up with at the end. And so notice the width of our box is this portion from here to here. Same as this one from here to here. So once this is all folded up and closed, it's only going to be that long from here to here. Alright, so if it was 5 the whole way, and you took X out here, and you took X out here by cutting it off, then this little portion, our width, for length times width times height for volume that we're trying to maximize here, our width is going to be 5 minus 2x, because it was 5 all the way across, and we cut X off each portion. Alright, then you can also see probably the next easiest one here. The height of the box is going to be X, because all these little flaps that get folded up depend on how much I cut out, then they would be bigger flaps. So the height of the box ends up being X. Alright, what about the length? Well, that's from here to here. And notice, since that gets folded in half, that this is the length of it. There's not 2 of them, right? So once it's folded up into a box, this ends up being the length. Well, first let's think, if I cut out all the X's, see how it was 8 all the way across? And I took an X out here, X out here, and X out here. So just these two pieces together are 8 minus 3x, because you took out 3 X's. But then if I only want one of those pieces, instead of both of them, they're the same size, so I could just divide by 2. So divide by 2 would give me 8 minus 3x over 2. Is the width of just one of these, which ends up being the length of the box. And then volume is length times width times height. And since they're asking us to use the graphing calculator anyways, there's no reason to FOIL or distribute any of this. We'll just type this equation the way it is into our calculator, and then we'll calculate the maximum so we can find how much X should we cut out of each piece, and what will the volume of our box be at the end. So now that we have an equation, we want to come over to our calculator and type it in so we can try to find the maximum. So this was over 2. You can write divided by 2 for over 2, but sometimes I like this little menu that makes fractions look like fractions. So under this F1, it's green, so you have to hit the green to get to it. So alpha F1, and you can use this all the time. You can use it on the home screen too. It's not just for graphing. So it'll give us what looks like the format of a fraction. So sometimes it just makes it look a little nicer. You can see everything at once. And then 5 minus 2x was the other part of our equation, and then times x. So we have these 3 parts, our length, width, and our height for our box. So we'll hit graph. And so here's our negative 10 to 10. So this is what X makes this a maximum. So it looks like right about here there's a maximum. So if I want to calculate that, I'll go to second calculate. And where is this maximum? So left bound is anywhere to the left of the maximum, so I'm already to the left of it. That works. Then go anywhere to the right of the maximum and hit enter. And then just guess where it looks like it is, and it'll give us a nice approximation. So 0.859, it says to round to 2 decimal places, so we'll call that 0.86. So that's how much you should cut out of each corner. And then when you do that, what will the volume be? Because this equation, remember, we typed in was the volume equation. You'll get a volume of 7.64, and I think this is all in inches, so 7.64 cubic inches. So now that we used our calculator to find out what the maximum was, we can say, okay, x was 0.86 inches is how much we should cut out of each piece, and then the resulting volume from that will be 7.64 cubic inches.